In this video, we are going to talk about graphing logarithmic functions. So first, we're going to sketch a graph of 2 to the x power. So to do this, I'm going to make a table of values. So x and f of x. You could also put y. You could start with any value. I'm going to start with -2, -1, 0, 1, 2 to kind of give me a range of values. So when I plug -2 into the equation, I'm going to get 1/4. When I plug -1 in the equation, I'll get 1/2. When I plug 0 in the equation, I would get 1, 2, plug in 2, I would get 4. All right, so now I'm going to plot these points. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. And you can see I have a curve here. And I would have my horizontal asymptote along the line y equals x. So my asymptote is at y equals 0. All right, now they want me to sketch a graph of the inverse function. So if I was sketching a graph of the inverse function, I would reverse the table that I had above. So x's would be the y's and y's would be the x's. So it would be 1/4 -2, 1/2 -1, 1, 0, 2, 1, 4, 2. So I'm going to plot those points. So 1/4 -2. So 1/4 -2. 1/2 -1. 1, 0, 2, 1, 4, 2. And so this would be what my function looks like. Now I would have an asymptote at x equals 0 for the inverse function. And our inverse is actually reflected over the line y equals x. So it also says find the asymptote. So we talked about that would be at x equals 0. And the domain and range. So the domain and range of the inverse would be the range and domain of the original function. So let's talk about the domain and range of 2 to the x. My domain for all exponential functions would be -infinity to infinity, and my range would be 0 to infinity. 0 is going to have a round bracket because it's going to approach 0 but never touch 0. So that means my domain for the inverse would be 0 to infinity, and my range would be -infinity to infinity, which is confirmed by our graph because the asymptote's at x equals 0, and it goes to the positive infinity forever, and it goes down and up forever. So range would be -infinity to infinity. So let's take a look at number 2, or 28. Recall the following functions, identify any asymptotes, calculate any intercepts. So we are going to graph it based on this function, and then we're going to do the transformation. So I'm going to recopy that table down here. And it's the same one I have up here. So 1/4 -2, 1/2 -1, 1, 0, 2, 1, 4, 2. Now, when I plot those points, I need to take into account that this is telling me I'm going left 1, down 1. So I'm going to plot 1/4 -2 right here, and then I'm going to go left 1, down 1. So I'm going to end up there. Go back and erase those other points. Then I'm going to plot 1/2 -1, but then I'm going to go left 1, down 1. I'm going to plot 1, 0, but then I'm going to go left 1, down 1. I'm going to plot 2, 1, but then I'm going to go left 1, down 1. I'm going to plot 4, 2, and then go left 1, down 1. So then I'm going to connect these points. And as I can see, my domain restriction is affected by the left 1 switch. So when I am determining the domain and range. My domain, since it went left 1 instead of being 0 to infinity, it's now going to be -1 to infinity. And my range is going to be -infinity to infinity. I can also see my asymptote, like I said, is here at -1. So I have an asymptote at x equals -1. All right, let's graph this next function. And again, I'm going to use the table from the other graph, which is the inverse of x and 2 to the x. So I'm swapping those. So if I did to the -2 power, I would get 1/4. -1 power, I would get 1/2. 0 power, I would get 1. First power, I would get 2. Second power, I would get 4. All right, now we're going to transform these points. So first I say I have this 2 in front, and that tells me I have a vertical stretch of 2. And so what that means is I'm going to multiply y by 2. All my y values are going to double. Then this -1 tells me that I'm going right 1. All right, so I'm going to plot 1/4 -2, so that would give me right here. Now I'm multiplying my y value by 2, so that would bring me down to -4. But then I'm going right 1, so it's going to bring me right here. And I'm going to do the same thing for all my points. So 1/2 -1, multiply my y value by 2, so that brings me down to -2. But then I'm going to go right 1, so my point will be right there. 1, 0. Well, 0 times 2 is 0. So I'm just going to go right 1. Then I'm going to go 2, 1 times 2 would bring me up to +2, and then right 1. And then I'm at 4, 2. Doubles becomes 4, 4, and then right 1. So again, that right 1 shift is going to shift my asymptote. So my asymptote is going to be at x equals 1. My domain would be 1 to infinity, and my range would be -infinity to infinity. All right, let's graph this next one. I'm going to copy this table down again so I can use it for reference. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. All right, so this negative in front means I have a reflection over the x-axis. So that means I'm going to basically multiply all my y's by -1. This +2 means I'm going up 2. So that's what I'm going to do to all my points. So first I'm going to reflect them over the x-axis. So if I'm at 1/4 -2, if I reflect that over the x-axis, I'm going to end up at 1/4 +2, and then I'm going to go up 2 from there. So my final point will start right there. 1/2 -1, reflect, ends up here, and then up 2 would put me right here. 1, 0, reflected, well, it's on the axis, so I can't reflect it, but I can go up 2, so it would be right there. 2, 1, reflected over the x-axis, puts me down in the negatives, and then I'm going to go up 2 from there, so it'll actually put me back at 2, 1. And then 4, 2, reflect that over the x-axis, puts me at 4, -2, but then I'm going to go up 2, so it's going to leave me on the axis. So my graph would look something like this. I can still see that my asymptote is at x equals 0. My domain would be 0 to infinity. and my range would be negative infinity to infinity. All right, so these last ones, they want us to find the domain and range and asymptotes of the following log functions. So again, the domain of the basic function is 0 to infinity, and the range would be negative infinity to infinity, and my asymptote would be at x equals 0. So if this is shifted just down 2, this is going to have no change to the regular domain or range. So my domain is still going to be 0 to infinity. My range is still going to be negative infinity to infinity. And my asymptote is still going to be at x equals 0. All right, in 32, we want to think about this as we have 2 minus x. So it's a little bit tricky, but really it's negative x minus 2. So the negative in front means I have a reflection over the y-axis. And so it's reversing my x, but I'm still going to go right 2 and then up 5. So when I think about my domain, if I'm reflecting it over the y-axis, that's switching my domain. So instead of going from a number to infinity, it's going to go from negative infinity to 2, because that's where my asymptote is going to be based on what's inside, how I'm going right 2. My range is going to remain unchanged. It's going to remain negative infinity to infinity.